I know. All right, so Descartes' rule of signs helps us limit the number of possible solutions. So you know how we do our little find all the possible roots, solutions, zeros, x-intercepts. This will help us limit that a little bit. So first of all, if I were to find all of these potential roots, we would do all of the factors of 9 divided by all of the factors of 2. So what are all the factors of 9? Excellent. And what are all the factors of 2? Good. So we should be pros at this. So we get 1 plus minus 1 plus minus 3 plus minus 9. Then we got to divide by 2. So we get 1/2. And we get 3/2. And we get 9/2. So determine potential rational roots. And then you're like, man, that could take me 1, 2, 3, 4, 5, 6, 12 tries, right? That would be rough. So use the remainder theorem to determine the real rational roots. And then, of course, we use the quadratic formula once we get down to a quadratic. So let's think about this guy right here. If it looks like this, how many solutions does this one have? How many roots, zeros, x-intercepts? It has 5, right? Because the exponent here, the highest power, is a 5. So there are 5 roots. And remember that of those roots, they will either be real or they will be imaginary. So we could potentially have 5 real roots and 0 imaginaries, right? Imaginary. And we could also have, because the imaginaries come in pairs, how many imaginaries could we have? Yeah, I could have 2, right, imaginaries, or 4. Let me write that out again, 2 or 4. Because they come in pairs. So if I have 2 imaginaries, then how many reals would I have? 3. And if I have 4 imaginaries, then how many reals would I have? 1. Notice that they are descending by 2, right? So you know you either have 5, 3, or 1, or you have 0, 2, or 4 of the other ones. And then think about this graph and how it's rising and falling. So since it's an odd exponent, it's definitely going to look like this, plus it's positive, okay? So how many times does it at least have to hit the x-axis? What's the least amount of times? Once, right? What if my x-axis was here? Then it would have to cross once, right? What if my x-axis was up here? Woo! How many times is that? 5. Make sense? So the least amount of times, it definitely has to hit once because it's alternating. One's up, one's down, right? We got opposite end behavior. Okay, so Descartes' rule of signs. The number of positive real roots of a polynomial equation with real coefficients equals the number of sign changes in the polynomial or that number less than 2. If that didn't make sense to you, it's okay. All we do, you guys, to figure out the number of possible positive roots is look how many times we change signs. So this guy right here is positive. This guy right here is positive. This guy right here is negative. That was a sign change right there. This guy right here is negative. That's not a sign change when you stay negative, okay? So the number of possible positive real roots is 1. And it has to be 1, okay? Now, what if I want to know the number of negative real roots? So to figure that out, we plug negative x in to this function. So first I'm going to actually be like, all right, I'm going to plug in negative x for every single x in the function. Okay, negative x cubed is negative, and we can pull that negative out to the front. So this becomes a negative 2x cubed. Negative x squared is going to be positive, right? I'm squaring the negative. So this actually stays plus 3x squared. And then here I'm going to have a negative times a negative. This makes a plus 7x, and then a minus 3. All right, once you plug in negative x, then you look for the number of sign changes. That's it, number of sign changes. So we start negative, and then we go to positive. So here's one sign change. And then it stays positive, so that's not a sign change. But here's another one right here. And so the number of possible negative roots is 2 or 0. You always descend by 2. So there were 2 sign changes, and you always go down by 2 because those imaginaries come in pairs, so you don't know if it's 2 or 0. All right? Now let's actually look at the graph and see the magic. So let's plug this guy in. So go to Add Graphs, f of x. And we're going to plug in the original function. So we've got 2x to the third plus 3x squared minus 7x minus 3. How many positive solutions do we have? 1. You guys know why this is a positive solution, right? Because this is like the positive x-axis, so that's like positive 1 point something. Oh. And then how many negative solutions do we have? 2. 1 right here, negative point something, and negative 2 point something. Okay? So did that match? Did we have 1 positive real root? Did we have 2 negative real roots? Yep. But we still always answer as 2 or 0 because you don't always have to check the graph. This is just for your own visual, see what we're actually doing. Okay? All right, so let's try this one. Determine the number of possible positive and negative roots for the following polynomials. Check on the calculator. So on your homework, you want to check on the calculator, but I want you to see what this looks like. So on this first one, all I'm going to do is, for the positive real roots, look at the original and see how many sign changes there are. So how many sign changes do you guys get? Ooh, some of you got 3. All right, let's see. Here's one change where it went from positive to negative. That's change. Here it's negative to negative. That's samesies. Right here it changes from negative to positive. That's another one. And then it stayed positive. So that's only 2. So for number of possible positive roots, what do we write? 2 or 0. Always descend by 2. So if you got 4, you would say 4, 2, or 0. If you got 5, you would say 5, 3, or 1. Just always descend by 2 because they come in pairs for the imaginaries. All right. Now we're going to do the negative roots. So for the negative one, you plug in negative x. Can I show you guys a little shortcut for plugging in negative x? Okay. So if you plug in a negative x and you take it to the 5th power, is that going to be positive or negative? Good. So it's going to change the sign here to negative 4x to the 5th, right? Now let's plug the negative x into the next x. So we have x to the 4th. So negative x to the 4th, is that going to be positive or negative? Positive, meaning it does not change the sign. So this is going to stay negative 8x to the 4th. If I plug in a negative x, do you want me to write out? Negative 8, negative x to the 4th. This becomes positive. Right? Negative times negative times negative times negative. All right, cool. Now let's plug negative x into this x squared. So is the sign going to stay the same or is it going to change? Stay the same because it's squaring. So it keeps the negative, changes it back to positive. Now I'm going to plug it into this one. Are we going to change the sign here or not? Yeah, it's a negative x. There's only one of them. So it's going to multiply by a positive 3. So it will change. Okay, so I just substituted in the negative x, evaluated my new function. Now we look for how many sign changes there are. How many are there? 1. See, same, 1. Okay. Let's just check this fun little graph just to make sure. So you guys plug it in. Again, this part you actually don't have to answer on the homework, but it's really good to see. Okay, and so you could sketch a little graph on your paper. It does say to sketch it. So you want to sketch it, but how many positive solutions are there on here? 2. Right here, positive. How many negative? 1. Does that go with what we said? It sure does. That is nice. Isn't that nice? All right, you guys are going to try the last one, and then we'll check it. All right, Thomas D., how many sign changes did you get for the positive, the original graph, or the original function? Okay, everybody get 1 sign change there? So if it's 1, it's just 1, and you're done. So we definitely know there has to be at least 1 positive real root. And when you look at the graph, that is what we got. Okay, now the number of possible negatives. So when you rewrote this, Anna D., what'd you get when you rewrote this? Okay, good. But first we got to plug in this negative x. What'd you get? Yep. 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 Okay, good. All right, and then you counted how many sign changes? 1, 2, 3. So we say 3 or 1. Okay. So why does this work? Well, we could also move this x-axis. So by the way, we do have 3 right here, right? What if the x-axis was here? Then I would only have 1 negative and 1 positive because this little part wouldn't go low enough. Those 2 would be imaginary if they don't cross right there. Okay? All right.